The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and thank you for joining us for the Municipal Concrete Pavement Design 101 webinar. In previous webinars, we have looked at benefits and advantages of concrete paving, as well as several municipal case studies. Today, we want to focus purely on design and what input parameters are necessary to allow one to design the thickness of a concrete pavement. We will explore numerous design softwares and resources available, and at the end, we will run through the design for the Harwood and Bailey intersection project using the PavementDesigner.org software application that's free online. Now, the Harwood and Bailey intersection project, we did a webinar on this a few months back, and we're going to provide an overview where you can access that information. Now, before we get to that point, my name is Alan Carey. I'm the Director of Technical Services at Concrete Ontario, and I will be your facilitator as always. For anyone new to our webinar, just going to run through some quick housekeeping items so everybody's aware of what the procedure will be. So it will be approximately a 45-minute webinar with questions and answers at the end. All participants are muted and will remain that way for the whole webinar. If you do have a question, please use the GoToWebinar questions pane on the right side of your screen and type in your question. We will address all the questions at the end. The webinar is currently being recorded and will be posted on the Concrete Ontario website, along with a PDF copy of this presentation, and the link is there on your screen. Now, if you have missed any of our previous webinars, we have been running a very successful webinar series about municipal concrete pavements. All the presentations and recordings are available on our website at rmca.org, publications and webinar presentations. So feel free to access that information and review any of the previous webinars that we have posted. Now, but my partner in crime, Tim Smith, is back to present. Tim is the Senior Director of the Built Environment, Transportation and Public Works for the Cement Association of Canada. Tim has 25 plus years experience in concrete pavements. He worked for a ready-mix supplier. He previously worked for Englobe, doing all sorts of designs for all sorts of different applications. And he is currently with the Cement Association of Canada, continuing on that great work. So good morning, Tim. How are you?
Good morning. Great, Alan. Hope you are too.
I am great. Thank you again for joining us. And I really do feel like this is your bread and butter, this presentation today.
Well, I do. I'm a bit of a geek. I love doing designs. So I enjoy going through the complexity of doing the concrete pavement design. It's a very interesting process.
It definitely is, and we definitely look forward to your presentation today. So I will turn it over to you now. You have controls.
Thank you. Okay. Thank you very much, Alan. Okay. Let's see if I can get control back here yet. Oh, there we go. So just a brief outline of what I'm going to be going over today. I'm going to do a little bit on the basics of concrete pavement. I'll look at the various components of concrete pavement structure. Then I'll look at load transfer, what that is in a concrete pavement. I'll do an overview of pavement design process and design methods, because there's a lot of them out there. But the main focus will be going through and looking at the PavementDesigner.org and doing an example of the Harwood and Bailey intersection. So the first thing we want to know, and it's very critical, when you're looking at a concrete pavement, the longitudinal joints are the joints that actually run parallel with the direction of traffic. So it's moving with the car, so that's your longitudinal joint. In the longitudinal joint, to make sure that you don't have a maintenance issue, you'll put tie bars. Tie bars are deformed rebars, and those are 760 millimeters long. And they're there to hold that concrete together so you wouldn't get an issue with the pavement pulling apart, moving over time, so you don't get a maintenance issue. The transverse joints, of course, run transverse to the direction of traffic, and you put dowels for load transfer at these joints. Dowels are 32 to 38 millimeters. They have a coating on them, and they're round. They have a coating called Tectol. And that allows the concrete to expand and contract as you're changing the temperatures through the seasons. Another important thing in the concrete is the surface texture. You can use a longitudinal tining, or you can use a transverse tining. I like the longitudinal tining because it's very quiet, but basically what it's doing is giving a channel for when you have wet conditions for the tire to push that water down into the joints and away from the tire to improve your tire pavement interface to maximize your safety when operating on concrete pavement. You also have your surface texture through the burlap drag and the sand within the concrete. It gives you your microtexture, and your microtexture gives you skid resistance. If you have a high siliceous content in your sand, you'll get a very good skid resistance and a durable skid resistance. Next thing is just to look at the difference in the loading, how loading is taken in the concrete pavement versus an asphalt pavement. Asphalt is a flexible system where it transmits the load from within the asphalt itself down into the base and down into the sub-base, and actually puts pressure down onto the subgrade as well. So it's more of a kind of a point load, depending on how thick the asphalt is, how far the load gets transmitted down into the base and sub-base. Concrete is a rigid structure. So what it does, it takes most of the load within the concrete pavement itself. The dowels are there to actually transfer the load from one slab to the other so that they don't reflect independently of one another, causing an issue with possible loss of fines underneath the pavement. So you have a very small pressure down into your base layer, possibly sub-base layer, and then you're down in your subgrade is much lower than the pressure that you would see on an asphalt pavement. So that's key to understanding concrete pavement design. So why do you use load transfer? Well, it's aggregate interlock is what your normal load transfer is. And when you have aggregate interlock, it'll make this slab and this slab act uniformly so that you won't get deformation of the pavement on one slab and then on the next slab. But as that aggregate interlock breaks down due to the traffic, you'll end up having what's called poor load transfer, and then each slab will act independently so that when you put a load on one slab, it will deflect down. When it goes over to the next slab, this one will rebound up and the other one will get down. That'll cause a suction in this area, and you can have possible, if you have a source of water in the fines, you'll actually get some of the pumping through the crack or through the sides of the pavement, and you'll get a gap underneath. And that's why you get sometimes in older concrete pavements that weren't fitted with dowels originally, you'll get that thumping noise that you hear on the concrete. So load transfer is extremely important. And the general rule of thumb is if you have 200 millimeters of concrete pavement, you normally will have dowels in that, unless you've made a conscious decision to have a little bit thicker pavement, and then you'll just use the aggregate interlock for the design life of that pavement. Your dowels, as I mentioned earlier, are usually 32 to 38 millimeters. When there are some designs that have shorter joint spacing, and they'll be 175 millimeters in depth, sometimes down to as low as 150. You use a smaller dowel of 25 millimeters so that you'll have the clearance required on the concrete so that you don't get any corrosion in your dowel bar. So this is just what we're going to be focusing today on is jointed plane concrete pavements. This design process that you can do through PavementDesigner.org has a lot of different options in it that you can use. But because we're going to be looking at the Harwood and Bailey intersection, I focused my presentation on jointed plane concrete pavements. As you can see here, this is a jointed plane concrete pavement where the dowel baskets have been placed out. Concrete pavement is actually going to be placed over top of these, and over to the right you can see the concrete pavement. This would be the end of the day transverse joint, where they've actually grouted dowel bars into the joint. You'll notice that you've got your crack down in the longitudinal, and it's down full depth, and you've actually had some dowels grouted in so that when they pour the next pour, it'll allow you to have load transfer across this construction joint. So when you're doing pavement design, there's a lot of different aspects that you have to consider. The first thing you have to look is what are the climatic conditions? What are you going to do Do you have a lot of sun? Do you have a lot of rain? Do you have a freeze-thaw environments? You have to look at the design for your pavement for whatever climatic conditions you're in. Another key thing is materials. Now, in your base design programs, you're not going to be looking heavily into this, but if you're looking at doing the design in AASHTOWare ME, you can actually put in the coefficient of thermal expansion of your aggregates for concrete, because that's one of the factors inputs that you put into the pavement design. So you're going to look at the material properties that are available in the area where you're going to do your construction. Then you have the pavement structure that you're going to be developing. What is that pavement structure going to look at? Do you have to design for frost because you have a very high frost penetration, so you might need a little bit more granular? What type of soil conditions do you have to build your structure on? You're going to have to look at that, and I have a slide on that shortly. But you have to look at your pavement structure. Then you have to look at what is the loading going to be on that pavement structure. And the combination of the climatic conditions, the materials, structure, and the load will create a response in that pavement that you've just built. And that response over time will create and accumulate damage. And the damage at the end will create stretches in your pavement. So you're trying to design for all these factors in your pavement design. Oh, there we are. Getting a little bit of a delay. So what I, in my opinion, is critical to any pavement design is a geotechnical report. So you want to make sure that when you're doing your design, that you have good information on the foundation that you're going to be building on. That's going to be your subgrade. So borehole logs are very important and have very important information in them. They'll give you the type of soil that has been taken out and tested. They'll give you a gradation of that soil. They'll let you know if there's a lot of excess fines or silt. Maybe you'll have to do some modifications to the subgrade because the plasticity index is very high. So when you've done your Atterberg limits, you may actually have to do some stabilization of that area of the subgrade. Or you might have some soft spots that you might have to remove. You'll know what your water content is, and you'll know about the uniformity. If you have changing various types of soils along the way, you're going to have to do some blending of that material when you're transitioning from one soil type to the other soil type. So in my opinion, the borehole logs or the geotechnical report is a very important part of any pavement design. So when you're looking at pavement designs, there's a lot of different methods out there. The AASHTO 93 design procedure is probably one of the most common ones that's been used. Developed by AASHTO, the road tests that were done. And this is really an empirical design procedure. They ran the vehicles around the track. They had the easel loadings that they did for that. And then they designed and had different pavement designs, and they analyzed the distress of each pavement design that was being driven over. Very good information, very good detailed information, but it is empirical data. Then you've got the most sophisticated program, the Darwin ME. This is the much more expensive program, but it actually allows you to go in and analyze those things that I've mentioned, the coefficient of thermal expansion, the Poisson ratio, a lot of detailed data on the concrete or asphalt side. Then you have StreetPave. StreetPave actually took the original PCA mechanistic design procedure, fine-tuned it, and then used the empirical information from the road test to help calibrate the model to give you a very good and accurate concrete pavement design tool, but not as sophisticated as the one that is Darwin ME, AASHTOWare ME. Another thing that's available is the ACI design tables. Now, these design tables are actually based on doing runs with the StreetPave program. And then now what's been created is the PavementDesigner.org. And it's taking the combination of the AASHTO design procedure of the WinPAS program that is produced by the American Concrete Pavement Association, the StreetPave, again, which is by the American Concrete Pavement Association, takes those, combines them together with the ACI process. So why is it being done? It's because there's an awful lot of different design tools out there to help you in your pavement design process. So what they're doing is they're making this design procedure available for people that don't have the other software or aren't well aware of how how it works. So if you're looking, also, as I mentioned, there's design tables available through ACI. There's 3 different categories of design tables that they have, depending on what you're looking at doing for your design, trucking facilities or concrete parking lots or streets. They have developed design tables within these different documents that you can go to. And basically what they do is they allow you to have a subgrade K value for your soil, depending on what type it is and your support conditions. You can estimate a value. You take that value, you then take the sub-base thickness and the type, whether it's granite sub-base or cement treated sub-base or other treated sub-base. You can put that in with the K value to give you a composite K value, depending on how thick that granular layer is over top of that subgrade. And that value is then used along with the amount of traffic and the strength of your concrete to come up with the thickness of pavement through these tables based on whatever K value you have, modulus of subgrade reaction. This is your composite value, which would be combined with the granulars. You take that, the strength, and then the average annual daily truck traffic to get your estimated value. Another procedure that's available, and I like to use this when I'm trying to do equivalent pavement designs and I want to compare an asphalt versus concrete. This is the Ontario one that was produced by the ARA. There's other ones that have been done for various provinces that were done by Thurber Engineering. So what it does, it allows you to look at if my strength of my subgrade is in one of these 3 ranges and look at the traffic that we're dealing with, it'll give you an estimated pavement structure for the concrete and a pavement structure for the asphalt. So you'll know what, if you're dealing with equivalent pavement designs when you're looking at one pavement structure versus another. So if we're looking at StreetPave, because that's one of the foundations of PavementDesigner.org, I thought what would be important is kind of look at some of the inputs that go into the StreetPave software. So first of all, you have truck categories that are built into it. There's, based on the interstate process, they have residential streets, collectors, minor arterials, and major arterials. So it's a distribution of truck traffic in the states for these 4 categories. They then took the ACI 330 tables for category A, B, C, and D and put that in this as well. And on top of that, it allows you to do an axle load spectra. And in my design example, I'm actually going to go over the axle load spectra because that was used for doing the Harwood and Bailey design. Another thing that you have to do is look at the truck traffic. What have you got for truck traffic? And this is the 2-way truck traffic value that you put in. You put in what is the growth rate that you're dealing with. Then you have the design life. Is it going to be a 20-year design? Or are you going to be doing a 30-year design, a 25-year design? You choose which one to do. Then you want to look at the directional distribution. Maybe the truck traffic isn't 50-50. Maybe it's 60-40. You can decide what that directional distribution is. And then you also decide, once you've done your distribution of the traffic, how much of that load is going to go in the design lane. Is it going to be 100%? Is it going to be 85%, 90%? You make that decision in your design, and you'll be able to do the same thing actually in the PavementDesigner.org. Other global design inputs are terminal serviceability. Now this one here is not actually included in the PavementDesigner.org, but it is in the StreetPave. Reliability is another one that you do. And the resilient modulus of the subgrade is very important input into the analysis. Then you have your general inputs. What is the percent slab cracks at the end of the life? You have a choice of doing 5, 10, 15, or 20, whatever value you want to put in there. You have your composite modulus of subgrade reaction, your K value. Then you have your subgrade, and that value actually can be calculated based on your resilient modulus of your subgrade and the thickness of your granular material. It'll actually calculate the resilient modulus for you. That's one aspect that the PavementDesigner.org doesn't allow you to do. Then you have you identify whether you have edge support, yes or no. And there's one that's also there that I don't have on my screen. It's fibers and no fibers. Then you actually put in the flexural strength, and the flexural strength, when you put that in the StreetPave, it actually calculates the modulus elasticity for you. The PavementDesigner.org does not do that for you. So it's just another little bit different to the software. So when you use this software program, you identify what your project is, you put your traffic in, there's a tab for doing the design details, and I went over those inputs already anyways, and then you go to your pavement run, click on this tab, and then you do your run, and it'll give you a printout of your analysis of how thick the pavement should be, and on the subsequent pages it'll go in and tell you the stresses from a faulting point of view and from a fatigue point of view that you're cracking. Now, another way of doing your pavement designs is the old AASHTOWare 93 design procedure. So WinPAS 12 is actually used to do that, and you can actually do a comparison of a concrete pavement design and asphalt pavement design. And part of this software is actually in the PavementDesigner.org, in that it allows you to input your asphalt pavement structure so that you can determine what the truck traffic is if you don't have that value. But I'll be going over that as well. So in your concrete pavement, these are the inputs that you would be putting. In your asphalt inputs, there's less inputs to put into it. But basically what you're doing, if you're going to be using this one, is you're going to use your asphalt pavement structure to calculate what the easel loading is, and then you take that easel loading and use it into your concrete pavement design so that you can determine what pavement thickness, equivalent pavement, concrete pavement thickness would be required in your design. And this is just a snapshot of the page that you can go and do the analysis side by side. These are your asphalt inputs. These are your concrete pavement inputs. And you'll see here that your asphalt pavement design can be entered in here. You'll put the layers, layer of asphalt that you have, your layer of base, your layer of sub-base. You put the coefficients. You can identify what the coefficient layer coefficients are. You put the drainage coefficient, and then you put the layer thickness, and it's going to calculate you a structural number. That structural number is used back in the asphalt design so that you can calculate your number of easels for your analysis by entering the rest of the data, and then you take those easels and your additional information on the concrete to back calculate and give you the concrete pavement thickness. So PavementDesigner.org then. So what do we have? We have, you can't really see it here, but this is your parking lot area. This is your street area that you want to do your analysis. This is your intermodal. It was designed by a cooperation between the Portland Cement Association, the National Ready Mix Concrete Association, and the American Concrete Pavement Association. These are the people that were heavily involved in the development of the tool. So as mentioned, and that's why I went over it in a little bit of detail, is it takes the StreetPave analysis process. It takes the AirPave analysis process for off-road vehicles. So if you're doing intermodal yards, you'd be using this if you have Rego Wagners or any other type of heavy equipment. And then it actually allows you to use a WinPAS program to back calculate that truck traffic for your design if you don't have that information when you're trying to do a comparison of the concrete versus the asphalt. This is the old PCA design procedure, so it's actually utilizing that as well. Then the guidance from NRMCA. And why did they do this? Well, I had shown a slide a little earlier. There's a tremendous amount of software out there right now that people can use. Then you have your ACI documents that people can potentially use. So they find people who say that it's challenging to know which software to use and the results that they get from them. So what they've done is they combined the information on the StreetPave, the WinPAS, and the AirPave together to develop a free online software. Its main area of use is streets and local roads, parking lots, intermodal, industrial facilities. And again, I'll only be going over the jointed plain concrete pavement design process, but you can actually do a continuously reinforced concrete. You can do concrete overlays. You can look at composite pavements. You can look at roller compacted concrete. You can actually analyze cement modified soils or cement treated bases and full depth reclamation with cement. And basically what this slide shows is if you're doing a parking lot, your parking lot is based on the PCA design method, the StreetPave, and as mentioned before, it's also based on the ACI design tables. If you're doing your overlays, these are the software that it's based on. And if you're doing streets, you actually have, if you join the plain concrete pavement, you're based on the PCA method and StreetPave, RCC, the PCA method and StreetPave, but no dowels. Then you have your continuously reinforced concrete pavements based on the AASHTOWare 93 design procedure. And then again, you can look at the composite pavements, concrete and RCC, asphalt surface. Those all can be analyzed, and the intermodal side, and that's using the AirPave with some modifications to the AirPave software. So basically what we're doing here is we're providing one software to allow you to do a whole suite of different types of designs, which is free online, and has broad industry support on the results that it provides. Myself, when I'm doing a design, I actually like to use the StreetPave software and this to check them one against the other to ensure that I haven't made any assumptions that I shouldn't be making. But it's always good to try to check at least 2 different design methods when doing a pavement design. So the roots of PavementDesigner.org, again, are the roots of the PCA design procedure, and the PCA design procedure is based on faulting and cracking. Those are the 2 failure modes that are being analyzed. And again, it's tailored for streets and roads. Now, one of the key things that you want to look at is that it does take a conservative approach when it comes to doing the calculation based on the fatigue. All concrete pavements are designed based on flexural strength. And because of that, when you do your testing, you're doing your testing with your system here, which has no support on it, and it's a small beam that you're testing. When you look at an actual load on a concrete pavement, you have a slab width instead of just a beam, and you actually have support underneath that beam instead of 0 support. So because of that, your K value, instead of being 0, could be substantially higher depending on the amount of granular thickness you have and the support that you have from your subgrade. And again, you have the slab effect. So it is a conservative design approach, but that's the best information that we have when we're looking at the flexural strength of your pavement. I just have a few slides on overlays. The overlay designs are based on utilizing the StreetPave, but it also references the BCOA, that's the bonded concrete overlay of asphalt. A mechanistic approach was developed by the University of Pittsburgh, Julie Vandenbush. It uses that method to do the design for concrete overlays. There's also a lot of documentation out there on concrete overlays that can be looked at. Now, when looking at, again, talking about heavy intermodal or industrial vehicles that are operating, the ACI guide actually gives some guidance on that as well, and AirPave. So the AirPave software allows you to input your normal inputs like your resilient modulus of your subgrade. You put in your flexural strength, you put in the modulus of elasticity. What you actually have to put in, unless you have your vehicle that's part of the provided built-in models, you can actually build your own vehicle by using user-defined, and that'll allow you to create based on your spacing of your axles and the spacing of the wheels within those axles and the tire pressure and the load on those axles. You actually can do your design. And normally when you're doing a design for a heavy vehicle, you'll analyze the axle that has the heaviest load on it. Then you'll analyze the all the axles together to see if what cause the zone of influence is on that pavement. So parking lots, again, you can use the parking lots information, can be done depending on what type it is. There's guidance on ACI for parking lots that is part of the PavementDesigner.org, and I had the table I showed a little earlier. And then you have StreetPave is actually very good for parking lots. Now, the key thing about parking lots, because you don't have the same channelized traffic that you would on a conventional roadway, you can actually have a much different footprint of your analysis. So you can actually go with a thinner pavement structure in your parking areas because you don't have that channelized traffic. So let's start and look at the PavementDesigner.org now. So we went back, we've looked at, okay, we know that we use StreetPave, we know we have the ability to use WinPAS, and AirPave all within this document, and we can do continuous reinforce. We're going to go through and do an example now on the use of doing a street. So your first slide, when you actually just go to PavementDesigner.org, you can go on, you can log in. You can create an account for yourself, or you can actually just go and do a design. If you create an account, you can actually go and save those designs. If we have time, what I'll do is I'll go and potentially show you a live demonstration so you can make modifications to your designs quite easily. But you can go in and sign up to get your information. And one thing that's key, anything that's saved in there, nobody has access to it because you password protect your own account. So only people that know your password can get in and take a look at your designs. So you select which one you want. Here I've selected concrete, so it gives you an indication of what is done for concrete pavement designs. When you go into concrete pavement designs, it has your overlays, your concrete or your composite pavements. So if you're going to go, I'm going to do a jointed plank concrete pavement, so I'm going to go in the middle one. It gives you a bit of description. It actually tells you the methodology that's used for the analysis when you're doing a concrete design. And just to highlight, Harwood and Bailey intersection at Ajax was actually done. There was a design, and I'm just going to be going over the inputs that were used for this. Now, one thing I've done, instead of using 300 millimeters of granular, I put only 100 millimeters of granular underneath it, just to show the difference that you'll get in the design. But you can go to the website and look at the presentation that Ben Wade actually did on this. It's one of our case studies. It was webinar number 3, case study number 1, and he gives a full presentation on this intersection. So the first thing you do is you have to do your project level data. So one interesting thing is you actually have a help function that if you want to know what the various inputs are, you can use the help function. You can turn it on or turn it off. If you don't want it to pop up when you move your cursor over the area that you're looking at, you can take it away. But if you move your cursor over it, it'll give you some instructions on about traffic. And if you want to click more information, it'll actually give you a breakdown. So it'll tell you that the categories that it gives you are residential streets, and it'll tell you the description of residential streets. It'll tell you the AEDT that it's based on, the percent trucks, the average annual daily truck traffic. It'll give you the whole details behind what the residential streets are. It'll actually show up over here. Your traffic axle spectrum will show up too if that's the one that you select. Same thing with collectors. It's there, minor arterials and major arterials. And then you have the user-defined one as well, which that's the one I'm going to show you that we did for Harwood and Bailey. So if you do put custom spectrum, this sheet will come up, and then you can actually enter in the axle for single axles, your tandem axles, and your tridem axles. You put the actual loads in, and the axles per 1,000 values are put in here as well, so that you can identify specifically what the type of traffic is in that intersection. I like using this process if you can, because it gives you a better indication of these general categories of residential, collector, minor arterial, and major arterial. You can actually know exactly what, if you have a traffic counter, you know exactly what you've got, and you can provide a better, more optimized design by doing so. So once you've chosen your axle load spectra and put it in, it actually will come up over here. Whatever you've entered in your user inputted axle load spectra will come up here. If you chose one of the other categories, the actual axle load spectra would show up here for whatever you did, minor, major, residential, or collector. That would show up here. Next thing you have to do is choose, okay, what design life am I going to use? So I put in the 20-year design life for this. So the next thing after that is you have your user-defined traffic. And there's two options for you here. If you know the amount of truck traffic and the other information I'm going to go over here shortly, you can enter it in. But if you only have an asphalt pavement design that you were given, you can actually do your design based on the actual, determine your truck traffic based on that design. And what you end up doing is you click on that, and it'll come up the same sheet that you'd see if you're doing the WinPAS program. You can come up and you can enter in your asphalt layer, your coefficient for that asphalt layer. You can put in your coefficient for your granular base and your granular subbase layer. You put in your drainage coefficients, and you put in your thicknesses. So those are as a capability that you have. Now there's some things that are set. The standard deviation is set. Your initial and terminal serviceabilities are also set. Unlike the WinPAS program, which you can actually input those yourself, or the StreetPave program, you can actually do your terminal one, input that value yourself. These are locked into this process, so it's not quite as flexible in the analysis, but it does end up giving you the results of a structural number, and it changes that into equivalent flexible easels so that you can then figure out how many trucks for your design life. So that's an option that you have, but it's always better to have the actual traffic. But if you have to bulk calculate that traffic, it is you do have that capability. So in this example, Harwood and Bailey, the design was based on the intersection having 1,600 trucks per day. They wanted a 2% growth in that truck traffic over the 20-year period. It was a directional distribution of 50-50, and they wanted 86% of the traffic was going to be in the design lane. So that's what was chosen. They also identified that they wanted an 85% reliability, and that they would allow 10% cracking of the slabs at the end of the life. So based on these inputs, this axle load spectra, the program will give you a calculated average trucks per day, and it'll give you a calculated easels. You can easily change those values. If you change the design life to 30, you'll see that it went from 6 million up to 10 million easels. So you can easily make modifications to this information to do what we would call a sensitivity analysis. And if you wanted to change your, wanted to see what the actual categories that are inputted into the system, what the design is based on those versus the design of your axle load spectra, you can also do that. So you have the ability to go through and do the sensitivity analysis and change your directional distribution number, change your design lane distribution as well, change your reliability. So once you've went through and done that and got your easels, you now go, and I put it back to the 20. So if you're back to 20-year design life, you can now, I like to save right there because I actually have an issue with computers. So I always go through and I save things at that point. As soon as I can save it, I save it. So I'll save my my data under PCCP intersection metric version because I first ran through this using the empirical design procedure because you have the ability to do both. So once you save it and then you move on, put I'll go back one. Here you have your pavement structure. Once you click that pavement structure, after you've saved the document, it'll ask you, okay, so you've put your project level information in here. What type of design do you want to do? Do you want to do jointed plain concrete pavement? Do you want to do a roller compacted concrete pavement? Or do you want to do a continuously reinforced concrete pavement? I chose to do the jointed plain concrete pavement because that was what was done in the Harwood and Bailey. So when you do that, you then come up with the pavement structure that you're going to build now. So the first thing it wants to know is, what is your subgrade? Do you have a known resilient modulus of the subgrade? Do you know the CBR value, or do you have an R value for the resistance value? So whichever value you have, you click the bar, and then you enter that value in. In this case, I knew that the resilient modulus of the subgrade was 25. So the next step is, what is my concrete strength? So you click the arrow. Do you have the 28-day fluxual strength? Do you have the compressive strength? Do you have the modulus elasticity? As I mentioned earlier, the modulus elasticity and the strength of the concrete are very related. Or do you have the splitting tensile strength? So whatever value you have, the software allows you to do that. So you notice, actually, when I put in my value for this resilient modulus subgrade, a value automatically comes up on the modulus elasticity. And that value is based on 600 PSI. Or when you're looking at concrete is 4.1 on the metric side, I believe. So another quirky thing on the PavementDesigner.org that you have to realize, a lot of times if you're looking at an MTO project, the fluxural strength, design strength is 5 MPa. For some reason, which I don't know why, the maximum strength that you can put in is 4.83 MPa for the fluxual strength. So when you put that value in, if you don't go in and do your calculation on what the modulus elasticity is, it will leave the 27,000 value that was there. So what I did is I went back to my StreetPave software and I put the value of 4.83 in the fluxual strength, and it calculated the modulus elasticity of 32,602.5. So that's what I used. So another key thing that you have to do is you have to decide whether you're going to have fibers or not. If you have fibers, in this design there wasn't, so I didn't use it, but you can click on fibers and then you can put in the quantity of fibers. Another very important aspect is the edge load. If you don't have tied concrete shoulders, concrete curb and gutter, I should say, and your wheel path is within 300 millimeters of the edge of the pavement, you will actually have edge loading, and you'd have to design for edge loading. So it's key to know what your geometry is of where your tires are and where the edge of your pavement is to do your analysis. In this case, there was edge support, so I put edge support. Next thing you do is, well, how many layers of pavement material do you have underneath your concrete pavement? In this case, it was already an intersection that was done, so I just chose one layer for that analysis. So again, you just click on this and put the amount of layers that you have. You then, once you've chosen the layer and identified it, you then choose what type of layer it is. There's cement treated base, full depth reclamation, there's lean concrete base, there's hot mix, bituminous stabilized, cement stabilized, lean stabilized subgrade, lime stabilized subgrade, and then there's granular base. So here it was just a granular base, so I chose granular base. So once you choose the layer, you've put the characteristics of the concrete and the subgrade, you put in the granular base and the thickness. I've used 100 millimeters. It'll actually calculate your composite K value for you. So you now have your structure done. So what you want to do is go to generate report, or what I would do is I save it first normally. So if you do generate report, it's going to tell you your thickness. So based on the information that I put in this sheet back here, you get using only 100 millimeters, you get 216 millimeters. And again, instead of being a 5 MPa flexural strength that there was for the design, I could only put 4.83. So this is actually thicker than it really should be. And I have a slide on that to talk about that. So, but what this slide does, it shows you the sensitivity of the K value in your analysis. It shows how the flexural strength will affect your design, how the design life affects it, the reliability, and the subgrade cracking, how those affect your design. You also can look at, and here's my save slide, so I saved it. It also allows you to look at the cracking. Okay, so what happens, what was the fatigue, what amount of cracking occurred in my design. It actually allows you to do the erosion. The erosion is really the faulting mechanisms, and how did it fail in fatigue or did it fail in faulting. Then it actually has guidance on load transfer and guidance on joint spacing. So then you save, hit the save button again, and this time you put the details of what your document was, where's the intersection, who was the designer, what route is it, what is the owner agency, and then some descriptions of the design. Then you hit download report, and a report will come out. And basically, based on the design, it'll give you your doweled analysis, and it'll give you your undoweled analysis. So you'll see by having dowels, you decrease the thickness of the pavement from 305 millimeters to 215 millimeters. It actually gives you your recommended joint spacing for the doweled and the undoweled pavement. And then it'll give you your details behind how much truck traffic you gave, percentages. So it gives you the detailed information that you put into the analysis, comes out on this report. It's all one, but I had to split into two pieces. So that's the type of information you get out of the report. So what I did is I then took the StreetPave software and I did the analysis at 4.83 and I did the analysis at 5 MPa. And you'll see that by increasing your strength from 4.83 to 5 MPa, your thickness is at 208. Look how close the PavementDesigner.org and the StreetPave values are, very close. And interesting, it was a little bit difference in the joint spacing recommended in the analysis. And if I changed my subgrade value from 100 to 300 millimeters, the thickness now went down to 200 millimeters when using the StreetPave software. So you can see that StreetPave does give you very similar answers to the PavementDesigner.org. So it is, it just verifies that the outputs that it's doing are very good. But again, you can play with a lot of things in your design, and that's why I always do a sensitivity analysis. Now, another interesting thing in this design software is there is a area on the left-hand side that actually allows you to go to resources. So if you click resources, it'll give you a video on how to use PavementDesigner.org for joint and plain concrete pavement. It'll give you a basic one. You can go to the wiki page and look at the overlay design procedure. You can also have a list of other resources that are available by utilizing the resource button. And then it allows you to, for support, it says that the 3 areas for support are ACP, National Ready Mix Concrete Association, and the Portland Cement Association. And then I'd like to acknowledge the Concrete Pavement Technology Center for allowing me to use portions of their presentation. I made a number of changes to Canadianize it, but I did have a lot of base information from the National Concrete Pavement Technology Center. It's a great area, great resources, great website to visit to get additional information on concrete. And questions?
Perfect. Thank you, Tim. I guess I'll start off the questions by asking, too many times we see designers use the exact same subbase for asphalt and concrete pavements. Is there any advice you can give to maybe newer designers that maybe don't understand the difference between the two pavements?
Well, I think the diagram I showed at the near the very first when I was going over the way a load is taken with the concrete and way a load is taken with an asphalt. An asphalt pavement is a flexible pavement, so it does transmit its load down into the base and the sub-base and actually down a lot of stress down on the subgrade. That's why the subgrade is so important for an asphalt. The stronger that subgrade is, the thinner an asphalt pavement structure can be. But with concrete, you don't have that load being transmitted down into those areas. So you don't need near as much material. MTO uses, for their analysis, they use, I believe it's 60% of the frost depth would be all you require for ground underneath the concrete. So you wouldn't need that you'd need more underneath an asphalt pavement than the concrete pavement would be required. You also have to look at what your soil conditions are. Do I have to make some modifications to my subgrade to ensure that it's not as frost susceptible, or are there pockets of that need to be removed? But you definitely do not need the same amount of granular material underneath a concrete pavement as you do an asphalt pavement.
Exactly. Great answer. I guess just one comment. Michael Beck, who did our previous case study with the city of Hamilton, just said, "Great presentation. Thank you very much." So that's definitely very encouraging. They're definitely emerging as the concrete champions in Ontario slowly. I guess an easy question: what does intermodal mean, or what does intermodal mean?
Intermodal is usually, and you talk about a rail. When you have CN Rail or CP Rail, they'll have areas where they'll bring the rail cars in and they'll be transferred over to transport trucks. So that's an intermodal operation. Or if you have a container facility where you have a ship and you're transferring that over into truck traffic as well. There are very heavy vehicles, Regal Wagners, Clark container handlers, straddle cranes. Those types of vehicles have very heavy loads. So when you're doing an analysis of that, what you do is you look at the individual axles of those vehicles. So you look at how many tires are in an axle, you look at the spacing of those wheels in that axle, and you look at the tire pressure of those, and based on the load and the tire pressure, it calculates the contact area, which actually calculates the stress on that pavement. So you need to do that when you have that heavy type of load. So that's what the AirPave software allows you to do, or the RCC software allows you to do, is to analyze those. And you need that type of analysis done when you have off-road vehicles that are causing more stress on your pavement than your conventional tandem, singles, and tridem axles from a tractor trailer unit.
Okay, thank you. The next question is, do you actually recommend for the industry to use PavementDesigner.org, or is it just more of a software to check compared to some of the other softwares?
Well, PavementDesigner.org is a good software that is available. If you want to put in a substantial amount of dollars, you can potentially use the AASHTOWare ME, but there's very few DOTs, I should say very few, a number of the DOTs have that, but there's very few consultants that actually have the AASHTOWare ME to be able to do the designs. So if you're someone that doesn't do a lot of pavement designs, I would suggest that this would be more economical because it's a free online system. But if you're a pavement designer that does designs on a regular basis, you may want to purchase the StreetPave software, which is only around $200, or maybe you want to go the whole 9 yards and spend, I guess, $8,000 or $9,000 on the other software available like AASHTOWare ME.
Yeah, so it really comes down to,
as I showed. Oh, go ahead.
Yeah, it really comes down to what is the budget of the DOT and how much can they actually afford to spend on software.
Yeah, and how often are you as a consultant utilizing that software? Because you actually have to charge, if you're going to buy it, you have to recoup the cost of it. So it all depends on how often you do the designs. But there's a really good information on how to utilize this PavementDesigner.org. But I still, even if I was using this, I'd still use the ACI tables or use our equivalent pavement design table that we have with us through ARA and Thurber Engineering. Those are very good to check your designs, as well as utilizing the StreetPave software itself.
Mm-hmm. Yeah, for sure. question about the Harwood and Bailey design you showcased. The difference was only about 10, I think they mean 10 mils between the doweled and non-doweled. Does that actually make sense?
No, it was actually substantially. You want to go back? Did I have control?
Or was it 10 centimeters?
Yeah, no, it was 305 millimeters versus 215.
Okay, so 10
So
centimeters.
you're talking
okay.
90 millimeters.
Okay.
Yeah, that's a substantial amount of concrete, because 1 inch of concrete pretty well doubles the load that you can take. So 25 millimeters. So there is a substantial difference by utilizing the dowels. They're a very cost-effective way of reducing the thickness of your pavement. The key thing is you install the dowels and the transverse joints, and you install the tie bars and the longitudinal joint. I've actually seen it done the other way. What happens if you use a tie bar in the transverse joint? It's going to hold that concrete together, prevent it from expanding and contracting like it wants to, and it's going to crack on one side of the tie bar. That happened in the project that I was called into after it was completed to give an explanation of why it happened. And then when I looked at the drawings and saw that the tie bars were used as the dowels and the dowels were used as tie bars, it was a very easy explanation.
Okay. The next question is pertaining to how do you actually calculate the modulus of the subgrade reaction, so your K value, and here it's 200 mil base plus 300 mil sub base. Can you just give a quick explanation of how you would calculate that? I know there's a lot more to it.
Well, I'll tell you what I do, because I have the StreetPave software. I go to the StreetPave software. I put my, the key thing is you have to know the resilient modulus of your subgrade. That value has to be in the geotechnical report that you've got. Otherwise, you have to go to MTO's tables, which gives you, there's two ways. So you can go to MTO's resilient modulus tables for the classification of your soil. It gives you good, fair, poor, and you choose which value to use. So that's your modulus of the subgrade reaction if the report doesn't give it to you. Then you go and put that value in your StreetPave program, and then I build my pavement structure, what layer I have for thickness I have for my base, what thickness I have for my sub base, if I have one, because normally a lot of times you don't have a sub base underneath the concrete. So I put that in, and it would calculate the composite K value for me. That's how I do it, because I have the software. There is on ACPA, I believe they're on their wiki page. They have actionability for you to input the values and it'll calculate the K value. Pretty sure, and I think that's in the reference documents on the left-hand side. If you click that, you can go in and look at all the wiki pages. But I think there's a wiki app that ACPA has available to do the calculation. Otherwise, you have to do it manually. And to tell you the truth, I've never had to do it manually because I always use the software.
Yeah, for sure. Have there any studies been done to compare the different platforms and which one is maybe more accurate of the other ones? I know there's obviously a cost factor looking at some of the more expensive ones versus like a free one like PavementDesigner.org, but does cost really play a big factor in how accurate the programs are?
Well, the most accurate is the one that has the most inputs, if those inputs have been validated. And that's why, or calibrated. That's why MTO is probably the most advanced in the use of the AASHTOWare ME, because they've calibrated a lot of portions of it. But a number of other DOTs are in the process of doing that. Manitoba and Alberta use it. Saskatchewan is just getting into the use now. Nova Scotia uses it. Quebec actually has their own software, but they do check their software with the AASHTOWare ME. AASHTOWare ME is a great forensic tool. If you have an issue with the pavement later on, it's great to go use to do a forensic analysis on what might have happened with the pavement. Why did it fail? The AASHTOWare ME is fantastic for that. But does it provide you with that much of an optimized design that it's worth spending that for only one project? Oh, I wouldn't think so, because the StreetPave software, along with the tables that are available through ACI, that'll provide you with a good, accurate design, in my opinion.
Okay. It looks like we're pretty much out of time, but maybe one last question. Depending on a pavement design, do you have to tailor your joint layout for, sorry, your, where's it here? Just moved up on me. Your joint detail, does it need to be tailored to every single pavement design, or is it a general joint detail?
No, every single pavement has to have. If it's just a roadway, then you're going to have a fairly standard design. If the software tells you that you want to have a maximum joint spacing of 4.57, you're probably going to use a 4.5, and that your whole pavement will have that. If you're looking at a parking lot, it's a different story, because parking lots always have obstructions. They'll have some curb and gutter. The parking lot may be angled. The parking lot might have some drainage basins in it, catch basins, manholes, etc. So if that's the case, you have to adjust your designs to isolate those obstructions and change the locations of them to ensure that you don't have cracks developing because you didn't think of that in your pavement design. Perfect example of that, and I think in the future we're going to have a presentation for the City of Vaughan Fire Station 7. So what was it? 7-3. 7-3. That one has a very detailed jointing pattern because it had so many narrowing of the pavement, widening of the pavement, curbs in it, and a lot of different obstructions, that it was a very detailed design. And so it's always important that when you're looking at parking lot, that you get an experienced pavement designer that knows jointing to do the jointing detail. The city tried to do it themselves. They sent it to me to review when I was at the Englobe, and I basically, it had aspect ratios were wrong. It had obtuse angle, acute angles, you should say. It had a lot of the rules that you follow, it didn't follow. So I would recommend highly that you hire a consultant to do complex jointing, but just general jointing on highways, it's much simpler because it's just follow the joint spacing, maximum joint spacing that's allowed. Don't go over that value, and you'll be fine.
Mm-hmm. Yeah, that's pretty much it, Tim. Thank you very much again for your insight. I know you put a lot of time into this presentation, and we had really good turnout today again. So again, we really appreciate all the information you're sharing with everybody. I think everybody learned a lot today, and it's really reflected in the questions, which are comments thanking you.
Oh, well, thank you very much. I enjoyed it. Like I say, I'm a bit of a geek. I love doing pavement designs and talking about it. So
and we enjoy listening to you.
And thank you, everybody, for paying attention.
Great. Thanks, Tim. So our next webinar, we are going to give Tim a little bit of a break. Again, he was definitely busting his butt all weekend to bring this presentation to you guys. So we are targeting January 28th for the next webinar. We have a few ideas, whether it's the 7-3 fire station that Tim mentioned from the City of Vaughan, or a presentation by the Ministry of Transportation of Ontario to highlight maybe provincial highways. We are in discussions with them, but we do believe January 28th will be the next day for our next webinar. So again, thank you everyone for tuning in. Thank you to Tim. And since we won't be talking to you before the new year, happy holidays to everybody. Stay safe and have a great new year. And we'll see you in late January. Thank you again and have a great day.
Take care and be safe, everybody. Thank you. Bye now.